Okay, Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad SHAFIQ HISHAM. Okay, class from class DEM 3A. Its the number is 14 DEM F191041. Okay, let's go. I explain you about force vector.
Okay, good evening everyone. My name is KARTHIGAYAN, son of SAMINATHAN. I am from DEM 3A. My entry number is 14DEM19F1043.
Hi and Assalamualaikum warahmatullahi wabarakatuh. My name is NURUL ATHIRAH BINTI ZAINUDIN. I'm from DEM 3A. My matrix number is 14DEM19F1045. So today I want to explain about my group report, force vector from group E.
Assalamualaikum. My name is FARULFITRI bin GAFAR. Matrix number 14DEM19F1047 from DEM 3A.
Okay, today I want to talk about the introduction and theory. A study of mention will involve the introduction of variety and equality that are used to describe the physical world. Examples of such quantities include distance, displacement, speed, velocity, and acceleration, force, mass, and magnitude, energy, work, and power, and etc. Okay, all these quantities can be divided into the two categories, vector and scalars. A vector quantity is a quantity that is fully described by both magnitude and direction. On the other hand, a scalar quantity is a quantity that is fully described by its magnitude. The emphasis is this unit is to understand some fundamental about the vector and to apply the fundamental in order to understand motion of force that usher into the dimension. Vector quantity are often represented by scalar vector diagrams. Vector diagram depicts a vector by use of arrow down to scalar in a specific direction. Vector diagrams were introduced and used in diagram earlier unit to depict the force action upon an object. Such a diagram are commonly called as a free body diagrams. An example of a scalar vector diagram is shown in the diagram below. The vector diagram describes the displacement vector. Except that there are several characteristics of this diagram that make it the appropriately down vector diagram. Okay, a scalar is clear list. A vector arrow with arrowhead is down in a specific direction. The vector arrow is a head and a tail. A magnitude and a direction of the vector is clearly labeled in this case. The direction shows a magnitude is 20 meter and the direction of is 30 degree west of north. Okay, now we see the mathematical method. The most common two dimension resolution of the force vector is into a rectangle component where fx and fy, the vector component of f and in the x and y direction, like this, and after that the force in x axis is fx equal to f cos 30 degrees and force in y axis is fy equals to f sin 30 degrees and force relation is f2 equal to fx2 plus fy2. Okay, now we see the basic theory and resolution versus equilibrium. A point of be the aware of is that the force needed to balance the system is not the resultant of the weight but is the negative of the vector, also called the equilibrium. This is the diagram, and okay, after that the R vector show is the resultant of the three vector f1, f2 and f3. If you make the R vector as f a zero magnitude, then if f1 and f2 and f3 vector are in equilibrium and their sum is equal to 0 as shown, and f1 plus f2 plus f3 equals to 0, or f1 plus f2 equals to negative f3, or R equals to negative f3. This means that when the sum of the three vector is 0, the resultant of any two as magnitude equal to the magnitude of the third one, and a direction opposite to the direction of the third one. And this the diagram, the resultant of the f1 and f2. Okay, now I want to pass to my friend to talk about the equipment and the apparatus.
Hai, Assalamualaikum warahmatullahi wabarakatuh. Nama saya Muhammad SHAFIQ KAMAL HISHAM. Hari ni saya akan menerangkan equipment, iaitu alat-alat yang digunakan untuk membuat eksperimen force vector ni. Yang pertama adalah force table. Dia adalah sebuah alat untuk menunjukkan hukum pertama Newton dan bagaimana vektor berfungsi. Ini selalu guna dekat dalam makmal fizik. Yang kedua adalah puli. Puli ni untuk melaraskan tali di selekor dan di lintasan sehingga geseran dan keausan dapat dikurangkan sebanyak yang mungkin. Dan dengan cara ini kekuatan mekanik dapat diterapkan pada suatu objek pada jarak yang jauh. Seterusnya adalah hanger lah. Hanger ni untuk tempat untuk menggantung, kalau dalam eksperimen ni untuk gantung pemberat. Seterusnya adalah weight, iaitu pemberat itulah. Pemberat ni diberi nilai yang berbeza. Nilainya antaranya adalah 100 gram, 95 gram dan 80 gram untuk tabel yang pertama. Untuk tabel yang kedua pula ialah semua sekali adalah 110 gram. Seterusnya adalah string. String ni tali untuk mengikat pemberat tu dan digantungkan kepada tempat gantung tu lah. Seterusnya protector. Protector ni jangka sudut, untuk mengira sudut yang kita perlukan untuk menggantung pemberat tu. Prosedur untuk membuat eksperimen ni. Yang pertama, kita siapkan dulu radas. Pastikan setiap radas dan equipment yang kita sebut tadi mencukupi dan sedia ada dan lengkap. Yang kedua adalah susun radas dan bahan seperti dalam rajah. Ada dalam lab sheet. Seterusnya gantung pemberat. Gantung pemberat pada sudut yang betul, yang telah diberikan. Untuk tabel pertama ni kita akan gunakan 100 gram pada nilai arah 112 darjah. Kemudian 95 gram untuk 244 darjah. Dan 80 gram untuk 0 darjah. Kemudian yang keempat, kita akan catat data. Catat data yang kita buat ni di dalam jadual hasil. Seterusnya kita hitung semua daya yang bertindak pada paksi X dan Y. Seterusnya kita ulang eksperimen ni dengan data yang kedua ataupun jadual yang kedua, di mana pemberat tu ditukar. Semua pemberat adalah 110 gram dan arah pun akan ditukar pada sudut 239 darjah 121 darjah dan 0 darjah. Okey. Dan ulang eksperimen 1 sampai akhir. Okey, dan rekodkan semua maklumat untuk kita buat ni lah perbincangan. Okey, itu saja. Assalamualaikum warahmatullahi wabarakatuh.
So, here I will explain about calculation and data analysis. This is table 3 that we need. The first one is 0.981. We first need to find the magnetic force on x-axis, Fx, and then magnetic force on y-axis, Fy, to get the direction. Okay. For the F1, to find Fx is 0.981 cos 112 equal negative 0.367. So for Fy is 0.981 sin 112 100 equal to 0.864 Newton. And then after we get this, we use this formula tan negative 1 bracket 0 the Fy 0.909 per negative 0.367, and then we get this answer 68.01 degree. Okay, for F2 is 0 to F2 force is 0.932. Also same, we find the Fx. For Fx 0.932 cos 244 equal 0.409. Fy, for Fy is 0.932 sin 244 equal negative 0.838 Newton. Then we get direction by using tan negative 1 bracket negative 0.838 per negative 0.409. Then we get this answer 63.98 degree. Then we get the resultant force equal to negative Ft. When we get this, the answer from 0.785 negative 0.785, and then we find the magnetic force Fx 0.785 cos 0 degree cos 0 degree equals 0.785 Newton. Then we find Fy equal negative 0.785 sin 0 degree equal 0. Then we get tan negative 1 per 0 per 0.75 equal to 0 degree. And then after here we add all this, find this, and then we get 0 Newton. Both of it. This is table 1. Force. And this is table 3 resultant force. Okay, this resultant, and there is a line here, and the F1, 2, and then we get this and this. Okay, now for table 4. By using doing same thing, the force for F1, F2, and F1 is 1.079, same like F2. Okay. And this resultant equal negative, resultant 4 equal negative F3, negative 0.1039. Okay, next we find the fx by 1.079 cos 239 equal negative 0.556. Negative 4 x is y-axis is 4y equal 1.079 sin 259 equal negative 0.925 Newton. And then we get direction, then plan, negative 1 bracket 0.925 per negative 0.556. Okay, the F2 is also the same. For resultant force, F3 equal 1.079 cos 0 degree equal 1.079 Newton. And F5 for F5 is 1.079 sin 0 degree equal 0 Newton. And then we'll get direction is 10 negative 1 0 per negative 1.079, and we got 0 degree. And then the force for all after we added 0 Newton, so also the same for F1 0 Newton. This is table 1 graph, sketch, force sketch, and this is a resultant force.
Okay, I want to explain about a discussion. A vector quantity has both magnitude and direction. A vector is usually represented by an arrow where the direction of the arrow represents the direction of the vector and the length of the arrow represents the magnitude of the vector. In 3 dimensions, a vector derived out of the page or along the positive z-axis is represented by a circle with a dot inside it, and a vector derived into the page or along the negative z-axis is represented by a circle with an x inside it. So I want to explain about the conclusion that I get from this experiment. Okay, from this experiment I learned how to do the triangle construction or parallelogram law of vector addition by using force table. I also understand the basic concept of force vector. Then I learned how to draw the force vector diagram to find and analyze the resultant force and direction from force vector diagram. We demonstrate the process of the addition of several vectors to form a resultant vector experimentally and graphically. By using this method, I am able to see how each method produces a slightly different resultant force, Newton, and resultant direction in degree. After that, the magnitude and direction of the resultant of several forces acting on an object was successfully determined by using graphical addition methods. It was also proven using a force table that the resultant or net force acting on an object at equilibrium is 0. Okay, so on my opinion, based this experiment, I gathering a lot of new knowledge about force vector. This experiment also really helped me to improve my skill calculation method about force vector.